Okay, let's get started. For this final project, I'm working on a Twitter bot detection project. Um, because nowadays on the Twitter platform, or you can call X platform, has a lot of bots or fake accounts. And these accounts are created to spread misinformation, spam, or manipulate the public opinions. My goal here is to detect these bots and take action against them. So, first of all, I need to find a data set about Twitter bot, and then I start train a proper model to detect whether the Twitter account is a bot account or not. So the data set is from the Kaggle, and as you can see here, initially the dataset have has a few columns, which includes some user ID, name, or some location, created time. But more importantly, we have the column called bot label. The bot label indicating whether the user is a bot or not. So it's more important for us to use it to verify our training model. So first we start download the model and doing something to take a peek on the dataset to see what data we have, right? And then I've done some data cleaning and handling values. Also, I've done some feature engineering. Um, As you can see, I've added a lot of new columns to the original data set. Something like I've done some analyze the sentiment on the tweet and then add the result back to the original data sets. Also calculate some retweet follower ratio or mention tweet ratio, as well as some other numeric like data. Um, yeah, I think before we take a peek on how many columns I've added back to the original data set, I need to let you know the distribution of the bot or non-bot accounts are evenly distributed on our data set. Yeah, this one is very important for us. Um, and for the cleaned data set, I've added some the column have grows to 41 columns. That's a lot. We cannot use all of them to do our data training. So then I need to drop some non-numeric and redundant columns. Um, for the initial process, I use something to calculate the correlation between the bot label and the other feature columns, to remove the negative value or non-value on the dataset. Then I draw the correlation matrix to like manually analyze which columns should be removed next. In here, we can see some redundant columns, um, such something like the tweet letter count and the tweet length, which is more it's similar. Yeah, it's almost identical. So we just need to keep one and to remove another. And also after done that, we have reduced the overall columns, but still we do not need those. It's still too many for us to do the model training. So I will continue to analyze the correlation and to remove the like the column which has lower values here. So we just keep like almost 7 features to do the model training. It's yeah, as you can see, it's like all of them are like over 0.005 relationships. And then I split the data sets into like 80/20, 80% of training and 20% of data set for testing. Uh, I also transfer, like use some technique to scale the data set to like to make their data set shape like to be identical. For model selection, I'm not like just choose one model over others. So I have written some program to do that for me. So in here, I use like I initially choose 4 training models. One is random forest classifier, and another one is logistic regression. And also I use the support vector machine to do that as well. It's called I think I choose two models. One is SVC RBF, another one is linear SVC. Um, so after done the calculation, and so it gives us the result, but it's difficult to like choose which one is better. You cannot just use I see which one is I see let's take a peek. Maybe you can see the logistic regression has a bad accuracy, but maybe it has lower recall or lower something maybe yeah it's not clear. So I just draw a plot chart to let you like to see all of the results. Um, as you can see here, it's the logistic regression is like slightly better than other models. It's not huge, just slightly better. So in here, just choose those logistic um, regression model for training. Yeah, but yeah, as you can see, the recall value of statistical regression is not as good as the random forest classifier. But yeah, but from other like model comparisons, we can see the accuracy and precision and LCUC is actually better than other models here. Yeah, after choosing the like training model, I will do some hyperparameters fine-tuning on the logistic regression model. Um, after done that, I use the best parameters to train the model. As a result, the like all the accuracy, precision, recall, RC, AUC values are like roughly approximately is 0.50. Also, I use cross-validation to evaluate the model, and the mean recall score is 0.43. Um, yeah, from the result, you can see it's not better because from the RC curve, you can see it's the value like it's close to the random choose, so it's not a better performance. So the conclusion of the first try is the logistic regression model achieved an accuracy of 0.50, but but the close but it performs like close to the random guessing, so it's not good. And also because we are doing the fault detection, the recall value is prioritized, but our model's recall score is like 0.43, so it will missing a lot of boats, right? So because of that, I think for the whole problem, the problem here is we have some limitations on the data set. Also, we maybe need to find some advanced machine learning techniques or additional data source. So after I done the first one, I started the second one. The second one actually I like look around and to figure out what went wrong, right? So in here, what I have improved is instead of manually to choose which features to use for training, I use the sklearn's feature selection to select the like top 5 features for us to do the training. Um, After done that, you can see the top 5 features from is differentiated from the previous one. In here we have the mention count, create add month, and username has bold patterns, username has repeating characters, sentiment subjectivity, and bold label. Um, yeah, so after getting the top 5 features, I'm going to like split the data set into the training and testing data set, and also doing the model selection. As you can see here, all the like if we see the accuracy, precision, or our CUC values, it's like similar. All of them are similar. But if we see the recall scores here, the support vector classifier with RBF kernel is actually performing better. So in this case, I'm going to use RBF SVC for this to like train our model. Before training the model, I'm still doing the hyperparameter fine-tuning on the support vector classifier. And after done that, we can see the like recall score is definitely improved. It's something around 0.65 and the accuracy is 0.50. And for the cross validation recall scores, it also gets 0.61. Yeah, it's definitely improved, but I like before, like I'm still not satisfied about the result because um, for the fine-tuning process, it actually takes a lot of time to fine-tuning the hyperparameters. It is actually difficult to find the best hyperparameters because in this case, I think maybe the best parameters I choose here is actually not the best for all the datasets because I'm not using all the dataset for this purpose. I just use the training data for like to do the grid search CV. So I think maybe I could try something like using the SVC RBF kernel without the hyperparameters. So then I use this one to like remove all the best hyperparameters and to train the model. As you can see, actually the recall score is improved and accuracy is the same as the like best hyperparameters. Um, if we like look closely on the cross validation recall scores, you can see the recall score, the mean recall score is actually increased. So in this case, I'm going to use this model, this support vector classifier with RBF kernel without like with the default gamma, default C values. So the conclusion for this training process is the SVC achieved an accuracy of 0.50, similar to our previous one. It's like close to the random guessing. It's no improve on the accuracy area. But if we look on the recall score, it's actually improved to the 0.72. So this means our model is effectively capturing the boats, but the cost, like the downside is we got the low precision. So it's actually not the best result, right? It's definitely not the best result, but it meets my goal. I can like use this model to detect if a Twitter account is a bot or not, from like for my personal use. If I got more knowledge for further improvement, I think I could like enhance the features for like the feature engineering process needs to be improved. Also, maybe I could like to get more data sets and get more like columns to the original data set. Also, for the like model complexity, I could try like different kernels or different hyperparameters, uh, as well as I could use some like different models, like for random forest classifier, right? Mm, yeah, I think that's all for me. Thank you.